All right, here we are on number 10, and it's giving us a function, and notice it's restricting our domain to being greater than or equal to 0. That's important. It tells us that we're supposed to show there's one maximum point on the graph and find the x-coordinate of that maximum point P. And so to have a maximum is when your derivative equals 0. It's also when you have a minimum, but this just wants me to show that there's one maximum. So I need to find the derivative of g. So I'm going to kind of do my work and erase it. So the derivative of g, this is a quotient. So I have to do the quotient rule, which is the bottom times the derivative of the top, which is just 1, minus the top, which is x, times the derivative of this. This is a chain rule. So the derivative of e to the x is, or e to whatever, is just e to whatever's up there. So I have e to the x squared. But because this function is more going on, I also have to multiply by the derivative of x squared, which is putting another multiply by 2x in front. All over the bottom squared, which is e to the x squared squared. And as gross as that is, I'm not going to worry about it because what I notice is that this has an e to the x squared, so does this. So if I factor out an e to the x squared, and this is why factoring is so important, I'm left with 1 minus, and if I multiply those, I get 2x squared, all over e to the x squared squared. But this guy can cancel with one of these. So this is what's left on top, and this is with the bottom. So this is my derivative. So I'm going to write that up here because I'm going to need that again in a minute. 1 minus 2x squared over e to the x squared. But what matters in finding your is when this equals 0 isn't when the bottom equals 0. That gives you issues that you can't actually deal with. I want to know when does the top equal 0. So I set 1 minus 2x squared equal to 0, and basically I add 2x squared to the other side, and I get 2x squared equals 1, and I get x squared equals a half, and I get x equals plus or minus the square root of 1/2. But my domain restriction is positive, so my answer is positive rad 1 over square root of 1/2, or 1 over square root of 2, or some of you are more official and would do square root of 2 over 2. Those are all exactly equal to each other. And so that is your x value for your maximum. And if you wanted to verify it was a maximum, you would make a little sign chart and you do 1 over square root of 2, and you pick a number to the right, like 1. And if I put a 1 in this guy right here, you will notice that that makes this 1 minus 2, which would be negative. And if I put a number between this and 0, like a half, if I put a half in here, this will become a quarter, and 2 times a quarter is a half, and so that would become positive, which means I'm increasing and then decreasing, and I just verified that it is a max. So now we move on to show that there's a point of inflection, and I tell you where the point of inflection is. Point of inflection happens when the second derivative equals 0, so that's why I kept this up here. I don't know why I wrote an F there. I need to find the second derivative. So the second derivative is still a quotient, so it's still going to be the bottom, which is e to the x squared, times the derivative of the top, and the derivative of this is going to be negative 4x. So I'm just going to write it like that so I don't accidentally think I'm subtracting, minus the top times the derivative of the bottom. Well, there's the top is 1 minus 2x squared, and we already know the derivative of this because we did it a minute ago. It's 2x times e to the x squared. So 2x times e to the x squared, all over top of the bottom squared, which is e to the x squared squared. And I'm going to kind of chintz a little bit here. I usually would factor these two guys out and then cancel, but we already saw that happen. So I know that e to the x, and this e to the x is going to go away with one of these if I factored it out. So that means the top of this is now negative 4x squared. And I got to distribute that 2x in here and the minus sign. So it's going to be minus 2x times 1, which is minus 2x. And then this is going to become 2x cubed. Oh, this is not 4x squared. This is only 4x. See? The derivative of that, the 2 drops in front, so there's no squared up there. That's pretty helpful for me in a minute. And then this 2x times 2x squared is going to give me 4x cubed, but a minus and a minus becomes a plus. And I can simplify this to 4x cubed, and these two can kind of merge together, become minus 6x. That's how I knew I had done a mistake. all over this e to the x squared. But again, I want to know when this is 0, so I really only care about when is the top 0. So 4x cubed minus 6x equals 0. I would factor this again. I would take a 2x out, which would leave me 2x squared minus 3x equals 0. I get 0 here again, which doesn't help me. And then I would solve this piece for 0. And if I solve that piece for 0, I have 2. Wait a minute, this x isn't here. See, I'm making mistakes all over the place. If I bring an x out, this is just 2x squared minus 3. So I have 2x squared minus 3 equals 0. So I add the 3 over, then I divide by the 2. Said it, but I didn't do it. I add the 3 over, divide by the 2, and then to solve for this, I take a square root. So x would be plus or minus square root of 3 halves, but I don't care about the minus 1 because I'm restricted here. And so I would use that as my point of inflection. So I just showed that this was a point of inflection because the second derivative equaled 0 at that point. I'm going to prove that, continue to prove that, and then also verify where the intervals of concavity are. So there's my 0 right there. And so what I'm going to do is I'm going to figure out what's going on with the second derivative at that point. And I just erased all of that work. So I'm going to put it back down. I had 4x cubed minus 6x. And again, I don't really worry about what's down here because nothing's going to make that 0. And no matter what I plug in, it's always going to be positive because it was e to the x squared. So this value is always going to be a positive number. So I don't need to worry about that. So I'm going to pick a number bigger than this. Now this is more than 1 because 3 halves is more than 1. So this square root's more than 1. So I can pick any number bigger than 1, like 5. If I put 5 in here, I'm at 5 cubed times 4 and minus 6 times 5. That's definitely going to be a positive number for sure. No way around it. That's pretty beastly and positive. And then I'm going to come over here and I'm going to pick a number less than this. So I'm going to pick 1 because I know this is bigger than 1. So I'm going to pick 1. If I put a 1 in here, I get 4 minus 6. That's negative. So I've just shown that I did change concavity at that point right there. So I sort of proved this value. And I also just answered this question. I'm now concave up when the second derivative is positive. So this is all concave up. So this answer is going to be rad 3 over 2 to infinity. Boop. And this is when I'm concave down. But remember, I only care about from 0 to 1. So from 0 to rad 3 over 2 would be when I'm concave up. And I don't actually know what's going on at 0 because it was actually possibly another point of inflection. So I'm not going to include that in that bound. Under part D, we're giving you a region bounded by the graph of G and the x-axis, which is like this guy right here, and a vertical line y equals k. So wherever our graph is over here, this is our vertical line k. Who knows what that graph looks like because we don't have a graphing calculator. But this is what I'm trying to find. And I want to show that the area is equal to this. And so area is when I take the integral. So I'm going to integrate from 0 to k. And this is what I have to integrate. And this is where I've got to do some of my integration skills. I've got x on the top and e to the x squared on the bottom. So I have a lot going on. So I am going to make, because I can tell that this is almost the derivative of this, I'm going to make u equal to x squared. And so du is equal to 2x dx. And I'm going to do the magic I usually do, which is this is not 2x dx, this is x dx, so I would have to put a 2 in here for it to equal all of this, which means I would have to offset it with a half. So I'm going to start rewriting this. I have a half. I'm going to integrate. This now is all gone because this is all equal to du. So I got my du in there. And this is in the bottom, but a u is x squared, so this is e to the negative u. And I'm going to change my bounds. If u equals x squared when x is k, then this would be k squared up here. That would become my top bound. And if I put my bottom bound in here, I would get 0. And now I'm going to integrate this thing. The half is a constant, it stays out front. The integral of e to the u is e to the u, but this is e to the negative u, which means I would have to offset it with an extra negative out in front. Now, if I took the derivative of this, it would equal e to the negative u times a half. So this is my integral, and it's basically like doing a secondary u substitution over here. but I know that the integral of e to the u is e to the u, so then this is not e to the u, it is negative u, so I'd have to offset it with a negative. Then I'm going to plug in my bounds of k squared to 0, and that means I'm going to have negative 1 over 2, and this, I'm just putting this down in the bottom now, because that's what the negative power does, k squared, right there, minus a negative 1/2. And again, I'm going to put this in the bottom, and I'm going to put a 0 in there, and e to the 0 is 1. So basically, I don't need this. Oops, that's way too big of an eraser. I don't need that. I just have the minus 1/2. And subtracting a negative becomes plus. And I'm supposed to show the value of k. So if I just, I am actually going to, I'm sorry for the time that this is going to take. I'm going to erase this so I can have some more white space to deal with. So if you need to go back, you can, of course, go back and take a look at that. I want to show, I know that this is the area, and I want to find the value of k. So I'm going to rewrite this as 1/2 minus 1 over 2 e to the 4th. That's just me taking this business. Now I'm going to take my business, and I'm going to restructure it. So this plus a half, I'm going to put in front because that's what I found for the area, minus, and I'm just going to put this in the back. And the only reason I'm doing that is because that's the way they gave this to me. So there's a 1/2, check. This and this look to be the same. So that means e to the 4 has to equal e to the k squared. And that means that k squared has to equal 4. That means k has to equal 2, plus or minus officially. And k doesn't have any restrictions, so k could be a plus or minus 2, I believe. And that is the answer to that one.